Good morning. Today we are continuing on with that probability, doing CO43. I can use probability to calculate the odds of an event. So probability and odds are two different things, and they're written two very different ways. I'm going to tell you right now, it's super easy to confuse which way we write stuff. Who can remind me, when we're writing probability, what do we put on the top and what do we put on the bottom? So if you don't remember, flip back. So when we first were, CO40, what was on the top? David? What you want to happen, your desired outcomes. What's on the bottom? What could happen, or all of the possible outcomes. So desired outcomes over possible outcomes, right? There's going to be a difference when we come to the odds, and it's important that we recognize and see that difference. So I need us paying attention. Probability of an event compares successful outcomes to total outcomes. It's like a fraction. Or the bottom of the fraction is how many altogether, right? 25 out of 100. So comparing successful outcomes, what you want, your desired outcomes, those are successful, your desired. Ooh, I want to pull a 3, and I do, it's successful. Out of total possible outcomes. Odds in an event compares the successful outcomes. So they both start with successful outcomes, but here's where the difference comes in. Odds compares the successful outcomes to unsuccessful. It's like a ratio. So we're spinning that spinner. There were 4 numbers on it. How many times are we spinning a 2? Right? If we spin that spinner 10 times and we spun a 2 3 times, there were 3 successful out of 10 possible spins. The odds would be 3 to what? If we spun 3 2s and there were 10 spins, we wanted that 2, so that's 3 successful to 10 spins. How would I change that up for the odds to put it as a ratio? I have my 3 successful to what? What do you think, Hadley? 7 unsuccessful. There is a difference between total outcomes and unsuccessful outcomes. It's not 3 to 10, 3 to 10, right? Here it was 3 out of 10 spins were 2s. 3 desired out of 10 possible. Here it was 3 successful outcomes. We spun those 2 3 times, but then we have to put what the unsuccessful number was. So that's a big difference between probability and odds. All right, so let's look at a standard 52 card deck of cards. So it's a regular deck of cards. We've got those 52 cards. We've got the hearts and the diamonds and the spades and the clubs, from ace up to king. in all 4 of those suits. We're gonna write the probability as a fraction and a percentage, and the odds of each event occurring, and we're going to answer in simplest form. Let's see what that all means. So what's the probability of choosing an odd numbered card? And he's telling us how many there are and how many total cards there are. So what would be the probability of choosing an odd numbered card? How should I write that? Robbie?
And you should write that by,
So when we're doing the probability, we're going to start with a fraction. So what would my fraction be?
20 over 52.
20 over 52. Now it does say answers need to be in simplest form. So how do I simplify that? Can I simplify that? Christina? So if I divided 2 out, 20 divided by 2 is 10, 52 divided by 2 is 26. Is that as simple as I can go? Christina? Yeah, I can divide another 2 out. 10 divided by 2 is 5, 26 divided by 2 is 13. So that's my simplified fraction. Now I need to write a percentage. So what would my percent be? Hadley? How did you get 38%, Hadley? Not 50, 5. 5 divided by 13, the top number, your numerator, divided by, that's that fraction bar, divided by your denominator, round to the 100th place, so you should get 38%. So that's our probability as a fraction and as a percent. Fraction in simplest form. Now, we need to write the odds of the event occurring. And that's going to be looking like a ratio. What is my ratio going to look like for the odds? Eleanor?
5 over 8. No,
Tell me how you got that.
I meant 5, the points and then.
Tell me how you got that.
I took the 13 and then subtracted 5 from it, because the 15 was.
So if we have 5 successful events, then that means that would be 13 total events. So that total events minus our successful gives us the unsuccessful. You could also say, well, we had 20 successful, and then 52 total, so 52 minus 20 gives us the 32, right? Then we simplify it down. We can divide a 4 out of those. 20 divided by 4 is 5, 32 divided by 4 is 8. We get the same answer. So you could work with your original numbers, or you can look at your simplified probability and say, okay, I've got 5 successful, 13 total, that's already been simplified down, I don't need to simplify again. Or you could go back to the original, 20 successful out of 52, so that means 32 are unsuccessful, and I'm going to simplify it down. So my odds are 5 to 8. Probability is 5 out of 13, 38%. The odds are 5 to 8. Successful to unsuccessful. Let's look at another one. What is the probability of choosing a face card? There are 12 face cards between all 4 suits. Harper. 12 over 52. 12 successful over 52 total possible. Am I done? No, I can simplify that. How do I simplify it down, David?
You can simplify it down by dividing it by 4.
12 divided by 4 is 3. 52 divided by 4 is 13. What would my percentage be? Luke? So that is my probability. 3 out of 13, 23%. What are my odds? Harper? 3 to 10. If I have 3 successful out of 13, that means there are 10 unsuccessful. Is that making sense? So the rest of this page, most of this page is the same sort of stuff. Let's look at the bottom. What does 3 to 4 odds mean? What does it mean if I say you have 3 to 4 odds? Robbie?
74%.
Nope. Odds isn't working with percentages. Percentages are a root of 100. That's not what this is. What does each side of that ratio mean? Christina? Nope. Michael? How many successful do we have? 3 successful, because that's our first number. So how many unsuccessful, Michael? 4. 4 unsuccessful. So for every 3 successful, there will be 4 unsuccessful. That's the odds. Eleanor?
It is like also like every 3 houses of 4 have.
No.
No.
No. We're just going to keep it simple. 3 successful, 4 unsuccessful. If it's on the left side, that first number is how many would be successful. On the right is unsuccessful. You were not talking odds with the example you gave. We were talking odds. Okay? So when we're talking odds, we remember one side's the successful, the other side is the unsuccessful. Our second page. So everybody put your calculators down. We are listening to these directions so we know what to do. Pencils down, calculators down. Pages are turned to that second page. Eyes are up here. Pencils are down. All right, that means all hearing these directions. In the game of blackjack, you and the dealer are each given 2 cards. Both of your cards and one of the dealers are face up. So this is the official way that we play blackjack. For each situation below, answer the question using probability as a fraction and percentage and odds. So just like we were doing on the front, pencils are down, thank you. Answers should be in simplest form, just like the front. Assume that you are using a new 52 card deck for each situation. So it's every situation, it's a brand new deck of cards. And since one of the dealer's cards is unknown, it should be considered part of the 49 other unknown cards in the deck. There's 52 cards in the deck. We know 3 of them. We know your 2 and Maddie on the table. We know your 2 and one of the dealers. So that's why it's out of 49 for the one that we don't know. The purpose of blackjack is to get as close to 21 as possible without going over. We call that bust if you go over 21, and you automatically lose. Each card has its numerical value. Base cards are worth 10 points, and aces can be worth 1 or 11. You are showing a queen and a 7. The dealer is showing a queen. What is the probability of drawing one more card and not busting? So if we are at 17, and we want to get to 21, what is our probability? So we see that number 16 here. What is that 16 telling us? What do you think, Eleanor? There are 16 possible successful outcomes. So he's telling us we don't have to do the math ourselves and try to count it out. He's telling us, pencils are still down because we're listening. He's telling us there are 16 successful outcomes out there. So how do I make that into a probability fraction? What should I do, Luke?
16 over 49.
Yeah. 16 successful over 49 possible. Can we simplify that? 16 and 49, can we simplify it down? No. So that's as simple as it gets. What will my percentage be? Now you can use your calculator. What would the percent be? Robbie?
33.
33%. 16 over 49 equals 33%. Now we need to put it as the odds. So my probability is 33%. What are my odds of not busting? Christina? If we do 49 minus 16, we get 33. So there's 16 successful cards, but there's 33 unsuccessful. Are the odds in your favor? No. There's a lot more unsuccessful cards out there. The odds are not in your favor. When you go to the casino, spoiler, the odds are not in your favor. So if you win big, stop playing, because the odds are not in your favor. Okay? Let's look at our next one. You are showing a 9 and a 9. The dealer is showing a 2. What is the probability of drawing one more card and not busting? Again, he's giving us 11. So what do you think we should put as our probability fraction? So what would the probability fraction be, Ruby?
11 over, I don't really get the second part, like dinner.
So we know 3 of the cards. We know that there's a 9 being used, a 9 being used, and a 2 being used. There are 52 cards total, but 3 of them have already been used. So we can't use them again. So how many total possible cards are there if we've used 3 of 52?
49.
That's where the 49 is coming from. We have 49 cards we're choosing from. So there's 49 total possible outcomes. 11 of those are going to be cards that will give us a successful outcome. We'll get to blackjack. We'll get close to that blackjack, to that 21, without going over. Can we simplify that? No, that's as simple as we get. So what is our percentage, Kathy? 22%. Now we need to find our odds. What would our odds look like? Keeping in mind that the 2 dots is called a colon. So when you write the 2 dots, we can say colon. What would the odds look like, Fallon? 11 colon 38, because those 49 total cards, if you take out our 11 successful, we're left with 38 unsuccessful. Is that making sense? Okay, you're going to finish up both pages. So go back to that first page. Don't forget you need to finish it. And then you're going to finish the second page, making sure you do that review on the bottom. If you're watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.